Our lecture is about regulation of the monthly rhythm, interplay between the ovarian and hypothalamic pituitary hormones. Our axis starts with the hypothalamus, where there is a certain releasing factor called the hypothalamic releasing hormone, gonadotropin releasing hormone, that in turn will stimulate the anterior pituitary 6 hormones, which are follicle stimulating hormone and luteinizing hormone, followed by the ovarian hormones, estrogen and progesterone, which are secreted by the ovaries in response to the 2 female 6 hormones that come from the anterior pituitary gland. These various hormones are not secreted in constant amounts throughout the female monthly sexual cycle, but they are secreted at differing rates during different parts of the cycle. The gonadotropins are secreted in short pulses, averaging once every 90 minutes as occurs in the male. We mean here that the pattern of secretion of gonadotropins from the pituitary gland is the same in both females and males. The normal reproductive years of the female are characterized by monthly rhythmical changes in the rates of secretion of the female hormones, with corresponding physical changes in the ovaries and other sexual organs. This rhythmical pattern is called the female monthly sexual cycle, or less accurately it's called the menstrual cycle. The duration of the cycle averages 28 days. There are 2 significant results of the female monthly sexual cycle. First, only a single ovum is normally released from the ovaries each month, so that normally only a single fetus will begin to grow at a time. Secondly, the uterine endometrium is prepared in advance for implantation of the fertilized ovum at the required time of the month. Gonadotropic hormones and their effects on the ovaries. The ovarian changes that occur during the sexual cycle depend completely on the gonadotropic hormones, FSH and LH, secreted by the anterior pituitary gland. In the absence of these hormones, the ovaries remains inactive, which is the case throughout childhood, when almost no pituitary gonadotropic hormones are secreted. Both FSH and LH stimulate their ovarian target cells by combining with highly specific FSH and LH receptors in the ovarian target cell membranes. In turn, the activated receptors increase the cell's rates of secretion and usually the growth and proliferation of the cells as well. Almost all these stimulatory effects result from activation of the cyclic adenosine monophosphate as a second messenger in the cell cytoplasm, which causes the formation of protein kinases and multiple phosphorylations of key enzymes that stimulate sex hormone synthesis, as explained in Chapter 74, Ovarian Follicle Growth, Follicular Phase of the Ovarian Cycle. When a female child is born, each ovum is surrounded by a single layer of granulosa cells. The ovum with the granulosa cell sheath is called a primordial follicle, as shown in the figure. Throughout childhood, the granulosa cells are believed to provide nourishment for the ovum and to secrete an oocyte maturation inhibiting factor that keeps the ovum suspended in its primordial state in the prophase of meiotic division. Then after puberty, when FSH and LH from the anterior pituitary gland begin to be secreted in significant quantities, the ovaries together with some of the follicles within them begin to grow. The first stage of follicular growth is moderate enlargement of the ovum itself, which increases in diameter 2 to 3-fold. Then follows growth of additional layers of granulosa cells in some of the follicles. These follicles are known as primary follicles. Development of antral and vesicular follicles during the first few days of each monthly female cycle. The concentration of both FSH and LH secreted by the anterior pituitary gland increase slightly to moderately, with the increase in FSH slightly greater than that of LH and preceding it by few days. These hormones, especially FSH, cause accelerated growth of 6 to 12 primary follicles each month. The initial effect is rapid proliferation of granulosa cells, giving rise to many more layers of these cells. In addition, spindle cells derived from the ovary interstitium collect in several layers outside the granulosa cells, giving rise to a second mass of cells called the theca. This is divided into 2 layers. In the theca interna, the cells take on epithelioid characteristics similar to those of granulosa cells and develop the ability to secrete additional steroid sex hormones, estrogen and progesterone. The outer layer, which is called theca externa, develops into highly vascular connective tissue capsule that becomes the capsule of the developing follicle. After the early proliferative phase of growth lasting for a few days, the mass of granulosa cells secretes a follicular fluid that contains a high concentration of estrogen, one of the important female sex hormones. The early growth of the primary follicle up to the antral stage is stimulated mainly by FSH alone. Then greatly accelerated growth occurs, leading to still larger follicles called vesicular follicles. This accelerated growth is caused by the following. Number 1, estrogen is secreted into the follicle and causes the granulosa cells to form increasing numbers of FSH receptors. This causes a positive feedback effect because it makes the granulosa cells even more sensitive to FSH. Secondly, the pituitary FSH and the estrogens combine to promote LH receptors on the original granulosa cells, thus allowing LH stimulation to occur in addition to FSH stimulation and creating an even more rapid increase in follicular secretion. Thirdly, the increasing estrogen from the follicle plus the increasing LH from the anterior pituitary gland act together to cause proliferation of the follicular theca cells and increase their secretion as well. Once the antral follicle begins to grow, their growth occurs almost explosively. The ovum also enlarges in diameter another 3 to 4-fold, giving a total ovum diameter increase up to 10-fold or a mass increase of 1,000-fold. As the follicle enlarges, the ovum itself remains embedded in a mass of granulosa cells located at one pole of the follicle. Only one follicle fully matures each month, and the remainder undergo atresia. After a week or more of growth, but before ovulation occurs, one of the follicles begins to outgrow all of the others. The remaining 5 to 11 developing follicles start to involute, a process called atresia, and these follicles are said to become atretic. The cause of this atresia is unknown. The large amounts of estrogen from the most rapidly growing follicle act on the hypothalamus to depress further enhancement of FSH secretion by the anterior pituitary gland, in this way blocking further growth of the less well-developed follicles. Therefore, the largest follicle continued to grow because of its intrinsic positive feedback effects, while all the other follicles stop growing and actually involute. This process of atresia is important because it normally allows only one of the follicles to grow large enough each month to ovulate. This usually prevents more than one child from developing with each pregnancy. The single follicle reaches a diameter of 1 to 1.5 centimeters at the time of ovulation and is called the mature follicle. Ovulation. Ovulation in a woman who has a normal 28-day female sexual cycle occurs at about the 14th day after the onset of menstruation. Shortly before ovulation, the protruding outer wall of the follicle swells rapidly and a small area in the center of the follicular capsule called the stigma protrudes like a nipple. In another 13 minutes or so, fluid begins to ooze from the follicle through the stigma, and about 2 minutes later, the stigma ruptures widely, allowing a more viscous fluid which has occupied the central portion of the follicle to vaginate outward. This viscous fluid carries with it the ovum, surrounded by a mass of several thousands of small granulosa cells called the corona radiata. Surge of LH is necessary for ovulation. LH is necessary for the final follicular growth and ovulation. Without this hormone, even when large quantities of FSH are available, the follicle will not progress to the stage of ovulation. About 2 days before ovulation, the rate of secretion of LH by the anterior pituitary gland increases markedly, rising 6 to 10-fold and peaking about 16 hours before ovulation. FSH also increases about 2 to 3-fold at the same time, and both FSH and LH act synergistically to cause rapid swelling of the follicle during the last few days before ovulation. The LH also has a specific effect on granulosa and theca cells, converting them mainly to progesterone-secreting cells. Therefore, the rate of secretion of estrogen begins to fall about 1 day before ovulation, while increasing amounts of progesterone begin to be secreted. It is in this environment of number 1, rapid growth of the follicle, number 2, diminishing estrogen secretion after prolonged phase of excessive estrogen secretion, number 3, initiation of secretion of progesterone that ovulation occurs. Without the initial pre-ovulatory surge of LH, ovulation will not take place. Initiation of ovulation. This LH causes rapid secretion of the follicular steroid hormone that contain progesterone. Within a few hours, 2 events occur, both of which are necessary for the process of ovulation. The theca externa, the capsule of the follicle, begin to release proteolytic enzymes from lysosomes, and these cause dissolution of the follicular capsular wall and consequent weakening of the wall, resulting in further swelling of the entire follicle and degeneration of the stigma. Simultaneously, there is a rapid growth of new blood vessels into the follicular wall, and at the same time, prostaglandins, which are local hormones that cause vasodilation, are secreted into the follicular tissues. These two effects cause plasma transudation into the follicle, which contributes to follicular swelling. Finally, the combination of both follicular swelling and simultaneous degeneration of the stigma causes follicular rupture with discharge of the ovum, and now it will be called corpus luteum. The luteal phase of the ovarian cycle, during the first few hours after expulsion of the ovum from the follicle, the remaining granulosa and theca internal cells change rapidly into lutein cells. They enlarge in diameter 2 or more times and become filled with lipid inclusions that give them a yellowish appearance. This process is called luteinization. The corpus luteum grows to about 1/2 centimeter in diameter, reaching the stage of development 7 to 8 days after ovulation. Then it begins to involute and eventually loses its secretory function as well as its yellowish lipid characteristic about 12 days after ovulation, becoming the corpus albicans. During the ensuing few weeks, this is replaced by connective tissue, and over months it is absorbed. The corpus luteum is a highly secretory organ, secreting large amounts of both progesterone and estrogen. Once LH, mainly that's secreted during the ovulatory surge, has acted on the granulosa and theca cells to cause luteinization, the newly formed lutein cells seem to be programmed to go through a preordinated sequence of proliferation, enlargement, and secretion, followed by degeneration. All this occurs in about 12 days. Summary. About every 28 days, gonadotropic hormones from the anterior pituitary gland cause about 8 to 12 new follicles to begin to grow in the ovaries. One of these follicles finally becomes mature and ovulates on the 14th day of the cycle. During growth of the follicles, mainly estrogen is secreted. After ovulation, the secretory cells of the ovulating follicle develop into corpus luteum that secretes large quantities of both the major female hormones, progesterone and estrogen. After another 2 weeks, the corpus luteum degenerate, whereupon the ovarian hormones, estrogen and progesterone, decrease greatly and menstruation begins. A new ovarian cycle then follows.